The Milky Way, our home galaxy, has captivated astronomers and intrigued stargazers for centuries. This colossal system of stars, gas, dust, and dark matter, held together by the mysterious force of gravity, is far more than meets the eye. Early astronomers, limited by their rudimentary tools, could not pierce through the cosmic dust that shrouded our view. They believed this galaxy was the entire universe, a canvas of scattered stars painted across the night sky. Yet, as technology evolved, so too did our understanding. By the 20th century, telescopes unveiled the staggering truth. The Milky Way was not just a cluster of stars but a graceful spiral galaxy, vast beyond comprehension. And contrary to human-centric belief, we are not at the center. Trailblazers like Galileo Galilei and Sir William Herschel reshaped our cosmic understanding. Galileo, with one of the first telescopes, revealed that the Milky Way's brilliance came from billions of dim stars, while Herschel concluded it to be disc-shaped. Then came Jacobus Kapteyn, who estimated our galaxy's colossal size, and Harlow Shapley, who dethroned us from our perceived central position in the galaxy. But it doesn't stop there. There is more to this cosmic tale. An intriguing secret about the Milky Way that it awaits to be revealed. Hey there, curiosity explorers. Ready for another dive into the unknown? I'm your host Caesar, and with me here is the talented commentator, Sonia.
Hey, explorers! Can't wait to embark on another adventure with you all.
That's the spirit. And folks, if you're enjoying this journey with us, be sure to subscribe to the Curiosity Wonderland, comment, and share with your fellow curiosity explorers. Until next time, keep exploring. You know, when we gaze up at the night sky, there's this soft, sweeping band of light that is just impossible to miss. It's mesmerizing, really. It arches across the expanse and sits near the horizon, a subject of human fascination for ages. The ancient Greeks named it Galaxy's Kuklos, or Milk Circle, and the Romans, while they called it the Milky Way. It wasn't until the year 1610 that Galileo Galilei, with the aid of one of the first telescopes, began to unravel this celestial glow. His groundbreaking observations revealed that the Milky Way's glow is a result of billions of dim stars enveloping our cosmic vicinity. And that's just the start of it.
That's fascinating, isn't it? An entire galaxy, our very home in the cosmos, was a mystery for so long. It's only now that we're starting to understand its vastness and our place in it. And it's not just stars, there's gas, predominantly hydrogen, dust, and even dark matter. All bound together by gravity, making up this vast system we call the Milky Way.
Exactly, and it's the challenge of understanding this that makes it so intriguing. We're trying to discern the shape and contents of a galaxy from within it, much like trying to understand the layout of a forest while standing in the middle of it.
And that's not even considering the limitations early astronomers faced. Small telescopes, limited range, and the interference of cosmic dust. It's like peering through a relentless dust storm. They thought the Milky Way contained all the stars in the sky.
Right. It really puts into perspective how much our understanding of the universe has evolved, doesn't it? So, the 20th century brought about significant improvements in telescope technology, allowing astronomers to look deep into space.
And this newfound ability led to the discovery that the Milky Way has a spiral shape, right?
Exactly, and it shattered the belief that our solar system was at the center of it all.
So, our Milky Way is just one of many galaxies out there. It's mind-blowing.
Absolutely. Now, let's talk about some early theories about our galaxy. Galileo discovered that the Milky Way was made of dim stars, those that seem less bright because they emit less light or are far from us.
But how could we know the shape of the galaxy if we're within it?
Good question. In the late 1700s, astronomer Sir William Herschel addressed this. He and his sister Caroline counted stars in over 600 areas of the sky.
And they found there were more stars in the Milky Way's band than above and below?
Yes, so Herschel concluded that the Milky Way was a disc-shaped structure.
And because he found similar numbers of stars in all directions along the disk, he thought the sun was near the center of the disk.
That's right. But around 1920, Dutch astronomer Jacobus Kapteyn used parallax to measure the apparent distances to stars.
Parallax, that's similar to how our thumb appears to shift against the background if we alternate between opening and closing each eye, right?
Yes, it's the same principle. Astronomers use this effect to measure the distances between stars. Astronomers measure the parallax angle and Earth's orbit radius to calculate a star's distance. This method is effective for stars within 50 parsecs. For farther stars, they use other methods involving luminosity.
And around the time Kapteyn published his model of the Milky Way, his colleague Harlow Shapley noticed something about globular clusters, didn't he?
He sure did. He noticed that these clusters had a unique distribution in the sky. Few were found within the Milky Way band, but quite a lot were located above and below it.
So, Shapley decided to map the distribution of these clusters and measure their distances, right?
Absolutely. Based on his observations, he concluded that the center of the galaxy was near the constellation of Sagittarius, and not the Sun.
That must have been a groundbreaking revelation back then.
It was. And Shapley also believed that spiral nebulae were separate galaxies outside the Milky Way. However, another astronomer, Heber Curtis, thought they were part of the Milky Way.
And who settled this debate?
That would be Edwin Hubble. His observations of Cepheid variables indicated that the nebulae were indeed separate from the Milky Way.
So, by the 1930s, they figured out that the Milky Way was likely a spiral galaxy?
That's correct. Hubble classified galaxies into various types, and since the Milky Way was disc-shaped like spiral galaxies, it was likely a spiral galaxy. Wow! I keep thinking about how amazing this world of curiosities is. So many discoveries, so many records, so many incredible facts. It's all so wild. What do you think, dear listeners? Isn't it fascinating to delve into these astronomical wonders and see just how far we've come in our understanding of the universe? Don't forget to hit the like button if you're enjoying the content. We're loving these discoveries, and we hope you are too. In the 1950s, the first radio telescopes were invented. These devices enabled astronomers to discover that hydrogen atoms emitted radiation in radio wavelengths. Importantly, these radio waves could penetrate the dust in the Milky Way, making it possible to map each spiral arm.
So, the tool to peer through the dust was finally there?
Yes, indeed. Astronomers then realized they could use certain stars as markers for distance measurements. These stars, belonging to the O and B classes, were incredibly bright, emitted multiple wavelengths, and had a relatively short lifespan of about 100 million years. This meant that they didn't move far from where they were born.
So, by mapping the positions of these stars and determining their rates of motion, we were able to get a clearer picture of the Milky Way structure?
Absolutely. By combining radio and optical maps, astronomers could trace the Milky Way's spiral arms. Interestingly, each arm is named after the constellations that are found within it.
And let's not forget about the Doppler effect.
You're right. The movement of stars affects the wavelengths of light we receive from them, similar to how the pitch of a fire truck siren changes as it moves away from us. Measuring this Doppler shift can tell us the star's speed and direction of movement.
That's kind of like how the color of a star can tell us if it's moving towards or away from us, right?
Exactly. If the spectrum of a star is shifted to the blue end, it's moving towards us. If the spectrum is shifted to the red end, the star is moving away from us.
And, based on Hubble's classification system, we now identify the Milky Way as a spiral galaxy, correct?
Yes, but more recent evidence suggests that it might be a barred spiral galaxy, a fascinating twist in our understanding of our own galactic neighborhood. Just to give you an idea of the sheer size of the Milky Way, it's home to hundreds of billions of individual stars and spans approximately 100,000 light-years in diameter. Our Sun is located about 28,000 light-years from the center.
That's an astounding scale to even imagine.
It truly is. The Milky Way structure is fascinating too. It consists of a galactic disk with both old and young stars, abundant gas, and dust.
And our solar system is located in one of the disk spiral arms, right?
Yes. We're in the Orion arm, alongside the Perseus arm, Sagittarius arm, and Scutum Centaurus arm. You know, this reminds me of a stargazing event I attended recently. As we lay there watching the night sky, our guide pointed out the constellations that make up the Milky Way's arms. It was a truly humbling experience to realize our place in the vast expanse of the galaxy.
What a coincidence. I also had a similar experience while visiting an observatory. They had a high-intensity telescope aimed towards the Orion arm. It was magical to think that we were looking at our own galactic neighborhood,
That does sound magical. It's also interesting to note that the Milky Way has a halo, a large dim area surrounding the galaxy, which houses hot gas, dark matter, and old stars. Most of the mass in the galaxy is found in this halo.
And didn't you mention the large and small Magellanic Clouds earlier?
I did. These are two satellite galaxies that orbit our entire galaxy. The Large Magellanic Cloud, which is about 14,000 light-years in diameter, may even be losing gas and dust to the Milky Way due to gravitational interactions.
Fascinating. And I guess luminosity plays a crucial role in how we study all of this, right?
Absolutely. Astronomers can calculate a star's distance from Earth using its luminosity. Stars like RR Lyrae and Cepheid variables, which change brightness predictably, serve as benchmarks. This is how Shapley was able to determine the luminosities of the globular clusters. Having determined the luminosities of the globular clusters, astronomers could calculate their distances from Earth. This leads to the rather exhilarating question: how many stars are there in the Milky Way?
You said earlier that it's home to hundreds of billions of stars, but how exactly is that number determined?
Well, you can't exactly weigh a galaxy on a scale. Instead, astronomers use the galaxy's orbital motion to estimate its mass. Newton's version of Kepler's third law of planetary motion comes in handy here.
So they use some complex mathematical equations to compute this?
Yes. With some algebra, an equation can be derived to calculate the amount of mass that lies within any circular orbit with a radius. For the Milky Way, considering that the Sun lies at a distance of 28,000 light-years and has an orbital speed of 220 kilometers per second, we find that there are about 100 billion Sun-like stars within its orbit.
That's impressive. I guess when we add the portion of the Milky Way that lies outside the Sun's orbit, it must increase significantly.
Precisely, the total comes to approximately 200 billion stars.
It's mind-blowing to think about the vastness of our galaxy.
Indeed, it helps put things in perspective. Earth is just one small part of the Milky Way, located about 2/3 of the way out from the center of the galaxy. The more we learn about our place in the universe, the more awe-inspiring it becomes. For those of you who might be interested in diving even deeper into the mysteries of our universe, there are numerous resources available that offer more detailed insights into our galaxy and the cosmos at large.
That sounds like a great idea. Adding to what we've learned in this episode would be fantastic.
Absolutely. There are quite a few noteworthy books on the subject matter that I'd personally recommend. For instance, The Cosmic Perspective and Astronomy Today are two fascinating reads that offer a wealth of knowledge on the cosmos.
I'll definitely look into those.
There's also an interesting online resource by NASA called Imagine the Universe. They have a book and a poster titled The Hidden Lives of Galaxies that might intrigue you.
That does sound intriguing. I'll be sure to check them out.
I'm glad you're interested. For more visual learners, there are great online tours like the Galaxy Tour from Discovery Education and NASA's multi-wavelength Milky Way. These offer visually stunning and educational explorations of our Milky Way galaxy.
I love the sound of that. There's something magical about exploring the universe visually.
It's a vast and beautiful universe out there, full of mysteries waiting to be uncovered. And the more we learn, the more we realize there's so much more to discover. It's indeed an enthralling journey of cosmic exploration. So, we've uncovered the fascinating journey of astronomers through time as they sought answers about the Milky Way, our very own galaxy. From Galileo's realization that its radiance is due to billions of dim stars, to Edwin Hubble confirming the existence of galaxies beyond our own. We also dived into how the shape of the Milky Way was determined and learned that the Milky Way is a spiral galaxy, approximately 100,000 light-years in diameter, with our solar system located about 28,000 light-years from the center. To top it off, we discovered that our home galaxy houses an estimated 200 billion stars. Quite a revelation, isn't it?
Absolutely. It's fascinating to think about the scale and complexity of our universe, and the more we learn, the more we realize how much we're yet to discover. It's a reminder that we're all made of stardust and inhabit a tiny planet in an incredibly vast cosmos.
Well said. It's like Carl Sagan once noted, we're made of star stuff.
Indeed. And with that, we'd like to thank you all for tuning into Curiosity Wonderland. If you enjoyed this cosmic journey, give us a cosmic thumbs up, or should I say, blast that like button.
And don't forget to share this episode with your friends. Let's spread the cosmic knowledge.
Absolutely. And do drop a comment about what you think of our celestial home, the Milky Way.
Your thoughts and curiosity fuel our journey through the cosmos.
We're looking forward to hearing from you. And until next time, keep looking up.
Goodbye everyone, and remember, stay curious. I found this gem of an article titled The Milky Way, Understanding Our Place in the Galaxy on the How Stuff Works website. It was penned by Craig Freudenrich, PhD, and Desiree Bowie, and published on November 1, 2023. If you're interested to explore more, you can find the link in our video description. Alright, now I'm off.